whether it's a legacy application in a VM, whether it's container-based, whether it's microservices, whether it's LLMs and agent-based, whatever you do, your primitives are kind of the same across time. But Alastair, you make a very good point on, the hardware cycles will stay reasonably long. But the question is, how can you take what they give you, which again is mostly the hardware part, it's storage, it's CPU, and leverage them in the best way possible? That's where it becomes important to not get stuck on, okay, I've dedicated this here, like that flexibility, right? The end of this project has come to an end, and now all of these resources are allocated here forever. But more like, how do you embed that elasticity of both CPU and GPU cycles that you can allocate them across the different outcomes that you're trying to build? And if that sounds too abstract, think about it this way. If you stick too much to that one lane, I've built it like this, it needs to be like this, and I need more of this hardware and software, your scalability is going to be very limited because you're going to constantly have to add more of this cluster, more. If you have a software layer that abstracts all of that's under that and exposes it to you as raw power and says, go use this, it's divvy it up across everybody, that's a lot easier to manage. And that can go in larger cycles as you can, buy, order, and actually get that order back in. So it's not easy, right? If most of your infrastructure was based on these infrastructure lifecycle cycles, which very much has happened, again, how do you rethink that? How do you pool resources together? How do you get away from bare metal and into shared resourcing and shared allocation and more allowing the intelligent system to prioritize and provision rather than you having to go and go like, okay, I should allocate this here for that and the other thing. So it's again, we're talking about how do you do things differently.
Right. And that's always been one of the concepts that VMware has done very well, is the idea that you can simply add resources to the pool you have, and they become elastic in that way. And you can also add workloads to the pool you have and consume the resources that are available. Just instead of allocating individual resources for individual projects, you can actually allocate them at a larger scale and hopefully make more efficient use of them.
I think there's been a big shift towards making that allocation, deallocation, reallocation part of an automation lifecycle process rather than being a relatively static thing where there's an operations team who do that balancing of resource on a weekly or monthly basis, shifting towards this idea of having a larger pool of resource that is dynamically carved up as resource requirements change. And this is no longer the operations team changing their resource requirements. It's more CI/CD pipelines leading to changes in applications being deployed out. Changes in the application configuration may then drive a change in the resource requirements. Maybe there's an optimization where we're going to use less RAM. That would be a great optimization tool at the moment as a trade-off to using more CPU time or maybe using a GPU to do some functions that would have otherwise done. Those kinds of dynamic changes is where we're going beyond simply pooling and sharing of resources with virtual machines to much more dynamic allocation and deallocation of resources.
Exactly. I mean, it's not just the CI/CD approach to it, but it's also the concept that there are ephemeral agents that run that will get spun up and run for a very brief time and get destroyed. And you need somewhere that you have the resources to actually run these things.